Hey guys, thanks for all the great videos. I just loved how you talked about stars. Thanks for sharing what you know. So we're going to learn about stars in the next this week and next week. So let me just kind of address some misconceptions. Um, the first misconception I'll address is about shooting stars. And so every time students ask me about this, I have to crush some dreams. So I'm sorry if I crush your childhood dreams. Um, so shooting stars are not actually stars. The stars that you see staying still in the sky, shooting stars are two different things. When you see a shooting star, that streak of white light or sometimes yellow light or sometimes maybe even in the daytime some red light, um, those are actually tiny pieces of dust or maybe a big rock from outer space that is basically crashing into the Earth's atmosphere. So we know that meteorites can impact the Earth. Most little things that come to the atmosphere burn up in the atmosphere before they get a chance to hit the Earth, and that's what we see as a shooting star. So the reason we have meteor showers is because as the Earth goes around the sun, sometimes the Earth crosses a big debris field, which causes lots of dust and debris to enter into the Earth's atmosphere, causing lots of shooting stars, or what we call a meteor shower. So hope I didn't crush too many dreams there. Shooting stars are not the same as stars, although we do know that there are stars that move rapidly compared to other stars. That's a story for another time, though. Another misconception I'll address. Actually, I'll address something lots of you guys got right. You said that stars are mostly made of helium and hydrogen. So most stars are made of helium and hydrogen. In fact, most of the universe is made of helium and hydrogen because they're very simple elements. So when I say hydrogen and helium, those are gases that we have here on Earth too. Helium is the stuff that makes balloons float. And our own sun, which is also a star, is made of 25% helium, and most of the rest of it is hydrogen. But it's not burning. So a lot of you guys said that their stars are big balls of burning gas. So it is true that they are made of something that's like gas. It's called plasma. You'll learn about plasma later. But it's not burning. Burning implies that it's something that's consuming oxygen. So whenever you set your have a fire on your stove or a campfire or something in your fireplace, that fire is consuming oxygen. It's converting oxygen and hydrocarbon into carbon dioxide and water. The sun isn't converting anything into water, or it's not even burning oxygen. The sun and all other stars have a different heat source called nuclear fusion, and that's actually one of the first things you guys are going to learn about on next Monday is nuclear fusion. Last misconception I'll address is just about where stars are. And so, like I said, the sun is a star. The sun is our closest star. You could probably tell it's our closest star just because how big it is. Most stars are about the same size as our sun, and some are a lot bigger. So if most stars are the same size as our sun, if not much, much bigger, and yet they appear as tiny, tiny dots in the sky, that tells us that they're very far away. And so when we think about our solar system is the place where the Earth is, where all the other planets are, and they move around the sun. There are no other stars in the solar system besides our sun. Our sun is the only one. And we have never left the solar system. The only spacecraft to leave the solar system is Voyager 1, potentially Voyager 2. You guys can look up more information about Voyager 1 and Voyager 2 online if you want, or you can ask me in a tutoring session. But it took them over 40 years to leave the solar system, going very quickly, faster than a bullet. So these stars are things that we've never visited. The sun is the only star that we really visited, and we can't even land on the sun. It's not like a planet where you can just put out your landing gear and land on the surface. First of all, there's no surface, and secondly, you'd vaporize before you even get close to it because it's so hot. So if we can't go to these stars, the question is, well, how do we observe these stars? What data can we collect? And lots of you guys said telescopes, which is right. The only thing that we have to observe stars is our naked eye or binoculars or a telescope. And what I'm really trying to get at here is that the only way that we know anything about stars is by observing their light. Their light is the only thing that tells us how they work. In fact, even the sun, well, we can't land on it. The only way we can learn about the sun is by observing its light. So in order to really understand stars, we need to know how light works. If we don't know how light works, we can't understand what stars are. And in fact, all the things that you guys told me about is that they're hot, they're made of hydrogen and helium. If we don't understand light, there was no way that we could have known those things. We can't even understand how big stars are without knowing how light works. So this week, you guys are going to learn about atoms and what atoms are, what atomic nuclei are, because we need to understand what nuclear fusion is, which is the energy source of all stars. We need to understand what those atomic nuclei are. And on Monday or next week, I guess around Tuesday, you guys are going to start learning about what light is and how light works. So that way we can understand what stars are as well. So I'll stop there. Again, thanks for the Flipgrid videos. Didn't have time to respond to every single one, which is why I wanted to give you guys this one. I know I kind of cheated because you guys were limited to 90 seconds and I got 6.5 minutes of your time. So hope you have a good day. Have any questions about this video, leave a comment on the post or on the video itself, and I'll see you guys later.